Greetings, welcome to my latest embedded Keras model onto a STM32 microcontroller. This is a big upgrade from the last one I posted back in October or so called Embedded Machine Learning. In that demo, I was basically trying to get it to work. I'd convert a TensorFlow tutorial to something that would work with X-Cube AI. And that one just had three classes, like a negative, neutral, and positive. This one has 5 classes. And also, it doesn't consume a database or an external source. We basically created a model off of my own data, the sentiment data. So that's helpful. So what I'm going to do is walk you through creating the model, extorting some MPY files to help us determine, create some inference data, and to help the X-Cube AI middleware analyze the model. And then I'll walk you through creating the project. So the first step is to clone this repository, and it's not a project per se. It gives you some files to use and some code to copy. So we'll walk through all of that. So we'll start with training the model. So here's my Python environment. So here's the file, and so we start with our training data, and we label these 0, 1, 2, 3, and 4. And those map to extreme negative, strong negative, moderate negative, positive, and strong positive. So running this trains and creates the model. So we'll go ahead and do that. So 100 epochs, and we're up to 100%. The next step is to load the model and create MPY data. And here's the output, cube_input.mpy and cube_output.mpy. The input describes the shape of the vector shape, which is 133 floats. And that's the shape that we're going to provide for inference, for example. And the output represents the classes. So we have 5 classes, 0 through 4, right? And so that information is going to be stored in here, and we'll use that later in this program. So it creates that file, and then it uses that information to create header and C file that we're going to bring into our project. It's going to have the inference data with the associated strings. Now what it does is it imports this other PY file that contains our different strings. These are not the strings that we train the data with. These are strings that express similar sentiment of the strings that we trained for class 0, and the same for 1, 2, and 3, and 4. And then we're using the MPY data to associate the 133 float value inference. So it's the actual inference that we're going to feed the model are the floats, and then we track these associations for user, ease of usability, so there's a good user experience. We're not like TensorFlow where you can actually feed it a string. We're not that full featured here on an embedded model. Also, these input and output files are going to be used with the X-Cube AI module or middleware for validation. So we'll go ahead and run this export. Okay, and here's the specifications. Here's the 133 elements for the inputs. Actually, it does not create the header file. I have the header file checked in. The header file just has some defines. This is the data. We have these 130. We have 5 133 floats for each one, and then we use these like parallel arrays, and I tie them together with arrays of structs. So here's the parallel array of sample inference text. And then the, see, did I miss? It must be above. Sorry about that. Okay, here's the output. And this comes from the MPY data. So these are associated with the classes. So now we have everything we need to begin a project. So that's the next step. So again, you should go ahead and clone the repository, and it's not a project, so don't try to build a project from it, but use it as to grab some files. If you want to use the model that I trained, if you don't want to train your own, and use the MPY files that are checked in, you can do that. Just take a shortcut and not do the training. Also, I have a syscall.c in there that you can plug in, and then you can copy the code from the main.c and the AI.c, but we'll walk through all of that. So we'll begin with starting a project. So right now I'm using my STM32F401RE. I validated it yesterday. In fact, the files that are checked in are with my H7. So it works for both. So we go to New. You want STM project, so it brings up the cube. I'm sorry this uses HAL. So, I mean, a nice go-to later would be to try to strip out all the HAL and get this very compact. But I'm just using HAL, generating code. This is not a small program. Here, let me find my board. I'll pause it. Okay, so here it is. I select it. Go to Next. And we'll call it STM32F4 demo. And yes, we'll just initialize everything to defaults, all the peripherals. So the first thing I do is I increase the RAM size for any of the boards to 1000 hex. Then back to pinout configuration. So we want to go to middleware, and you want to find Xcube AI, and then you want to select core, and as far as the application, pick application template, then OK. Then you select it again, and it brings this up. You hit this plus sign, you're going to add a new network. Okay, so here's the cloned files. I'm sorry this is kind of small, but you can grab these and copy them local. So keep this fresh, because I think that the Xcube AI, it edits, it turns it into a blob and it messes with it. So you don't want to create a new project with something that's already been imported into a project. So we'll grab this, the Keras, the input, output, copy it. I just paste them right to the project root. Now don't be tempted to put in syscall yet. One thing you might do is rename syscalls.c so that it doesn't get overwritten by the generator, but I'm going to wait to put it in until after the code generation step. Okay, so now that we've copied that, let me make this a little bigger. So you see we added the network, and there's a browse here, and this is where we pick the model. So we go to where our file is. And there it is, sentiment model underscore v2.keras. We select it, and then go ahead and leave compression none and optimization balance. But for validation input, we want to select the input.mpy and the output.mpy for validate outputs. And then go ahead and analyze. You have to have your board plugged in. So I'll pause it while it's doing this. Okay, it's complete. And by the way, it writes this file to your project underneath network output. Underneath, actually, it gets written to your repository underneath your username, but it does show in your project. They do link it into your project so you can look at it. We're not going to look at that now. We covered that in the previous video, in the embedded machine learning video from 6 months ago. And then you can validate on desktop. I'll pause for that too. And so that's completed. So I believe we're ready to generate code. So the way I do it is I go save. You know, I think this is a bug because it still shows a little asterisk here that it's not saved. So I'll put the focus on the .ioc here and go Control S. Yeah, here we go. You want to generate code. Another thing I do too is I build first. And it's going to give errors because I don't have syscalls.c, but I've experienced it wanting to generate code again on build. So let's do a build. Yeah, okay. So now it's time to import that syscall.c. By the way, you can import the model that you just created if you did, or use the one I have checked in. It should be the same. And the same thing with the sentiment_vectors.c. You can use the one you just generated, or use the one I have checked in. And then sentiment_test_vectors.h is a header file that you'll have to include. So I'll do that first. We'll copy it. We'll go to Core Inc., select Inc., and say paste. And there it is. Then we'll copy sentiment_test_vectors.c, copy, select source, paste, and let's give that a build. Okay, we're still good. Okay, now with this next part, I just like to use the code in off of the GitHub. We can copy that. So let's start with main.c. Main.c, we're going to want to copy the include, both stdio.h and sentiment_test_vectors.h, and place it into the user code begin. Then we want to get rid of this. We don't want to run this mx_cube AI process in the while loop unless you have something designed for that. But instead we're going to put in our for loop that terminates, doesn't run forever. And well, first we'll get our variables. And where we put that, that's code begin private variables. Right here. By the way, while we're here, please note the name of your UART instance. Here it's HUART2. For my H7 it's 3, so if you copy the right file you should change it. If yours, just pay attention, make sure it matches when you put in your _write system call that you're going to override to get UART printing. Now if you're running a different board than my H7 generated these SCB enable iCache and Dcache, and it made the debugger run nuts. I just commented it out and everything works great. So that's what I recommend. So down here is our loop. So I have something called init test cases, which initializes these structures, associates the inference data with these structures. And you can take a look at that. It's in sentiment_test_vectors.c at the bottom of the file. But we'll go ahead and select this, the init test cases, and then this loop. Copy that and put it in the user code begin to block here. Okay, then the next we do want to get the right file. I mean the right function. Pass it up. Here it is. So again, here it's UART3. That's what I needed for my H7 board, but I'm going to need 2 for this board. So I'll change that right here. So UART2. Okay, so that's it for main. Now the next file we want to edit, and the last file, is you go here to, here we'll expand the project. So the name of my project here is STM32F4 demo. And so we're done with core, okay? And so now we go to xcube-ai, and there's app, and this very first one, app_x-cube-ai.c. So the first thing we're going to want to do is in user includes is include our header. So I'm going to open that file up in GitHub, just view it, and right here in the user includes, we'll grab that and put it here. Next, we'll grab our user data and user functions. So these point to some buffers in main that we assign to the AI, internal AI buffers. These sentiments are just for reporting, not part of the model. So down to user code 2. Yeah, right here. Then we're going to replace the two, so the acquire process data and the post process, we're going to totally replace these. These are still in the user code sector. So we want, oops. Both of these functions. Oh, by the way, I forgot to show you something that we need to do now. Copy. Oops, here. Make sure not to overwrite the user code markers. Okay, so it's giving me squigglies here, which is very helpful because it's telling us that we need to enable in properties, in build settings, in MPU settings, we need to check this, use float with printf with the new lib-nano. So we close and apply that, and our squigglies go away. So let's build that. Let's see, are we ready? No, we got to do one more thing. So in this MX Cube AI process, it goes into this while loop, and I get rid of that. And so we go down, and I just grab the code that is within the user code markers, not the whole thing. I'll just grab that and go here and just replace it in between the user code markers, right to there. Okay, are we done? I think we are. So get out your favorite COM port reader. I like the Texas Display by John Valvano. You can use PuTTY. My board uses COM port 3. Check your device manager settings. Right now the baud is at 115200. Make sure they match. Then open the port. Okay, so start debugging. So we'll go ahead and do a debug as STM application. Okay. Okay, I'm going to clear because it's still the UART has some from the last session. So we'll go so we'll go ahead and step. Let me make this smaller so I can put the COM port reader here. Let me make it smaller too. Okay, so this is the reader, and it's going to catch the printfs. So iteration 1. So it's setting up the buffers, and now it's calling the process that operates on it. And there you go. Sample 1. This was absolutely terrible, and so on. So I'll go ahead and hit F8, do the whole thing. And so there you go, the full report. And so that's about it. That's how you do it. That's how I did it. You can experiment with it and create your own strings based on whatever topic you want and label them with sentiments and train it, and then come up with inference data, strings that you'll have to use your discernment to make sure that the sentiments are similar, and then run those scripts to do the associations and create. The problem is you'll have to replace your training strings and your inference strings inside those scripts, and then do the steps that we just did. Anyway, I think that's it. Let me pause and think to see if just reflect a little bit, see if I missed anything. No, I think that's about it. So I'll upload this video and give a link to the repositories, a link to the previous demo in that repository. So 23 minutes. Well, thanks very much for your attention.